All right. Hey guys, so I hope you recognize me, but if you don't, my name is Jacqueline. I'm your guys' SI for this quarter. And for this video, I'm going to be talking about indefinite integrals, right? So I think the best way for us to do any kind of math instructional video is to go through an example and really get nitty-gritty with it. So I have an example posted. First thing that we want to do is we want to look for some type of pattern or category to kind of break our integral into. And the reason that we want to do this is in case that we have a more complicated integral in the future, right? We can break it into smaller, more manageable pieces. So for this, I'm going to break my integral up as such because I recognize that this 1 over x does not look like x squared plus 3x, right? 1 over x is a rational function, x squared plus 3x is a polynomial. So I'm going to break it up right there because I recognize hey, something's not right with that, so I can just pull them apart, right? Our integrals rules say that we can do that. So now I have these two separate integrals, and next thing I should realize is this piece right here. The reason that I'm focusing on this piece first is because from 9a, I should recognize from my derivative rules that 1 over x is the derivative of the natural log of x, right? So if 1 over x is the derivative of the natural log of x, kind of logically, if I understand that the antiderivative is kind of like the opposite or what undoes the derivative, logically, it's natural for me to assume oh, the natural log of x then is the antiderivative of 1 over x, right? That makes sense if you think of it, if you think of the antiderivative as the opposite or the undoing of the derivative, right? So since 1 over x is the derivative of the natural log of x, the natural log of x is the antiderivative of 1 over x, right? Okay, for this piece right here, I'm going to be doing what I call the reverse power rule, right? So what this does is, for polynomials, well, we know how to take the derivative of polynomials, right? We use the power rule. Since we're taking an antiderivative of polynomials, what we can do is we can undo that power rule, right? So we're going to go backwards with the power rule because we're doing an antiderivative, right? So since we're going backwards from the derivative, we have to go backwards from the power rule, right? So the way that this works is we're going to kind of go through it component-wise based on the power rule, right? So the power rule says that I'm going to subtract 1 from the exponent and multiply by that new exponent, right? Since I'm doing the opposite, right, of the derivative, I'm doing an antiderivative, I'm going to be doing the opposite of the power rule. So I'm going to be adding 1 to this exponent, right? That's the opposite of, whoops. So I'm going to be adding 1 to this exponent, right? Because that's the opposite of subtracting 1. And then I'm going to do the opposite of multiplying, right? Which means I'm going to divide by this new exponent, right? So I simplify that down, I get something like x cubed over 3, right? This plus here drops down. Another thing that drops down is this 3, because 3 is a constant in front of a variable, so we can just drop it down like that. And since for this free x right here, we're going to be doing the same thing, right? X is a polynomial, we can reverse power rule it, right? So again, with the reverse power rule, I'm going to do the opposite of subtracting 1. So I'm going to add 1 to the exponent, right? So x has the invisible 1 exponent. So we're going to add 1 to that. Then I'm going to divide by this new exponent up here. So that's 1 plus 1, right? Now I'm going to simplify that a little bit, and I'm going to get something like x squared over 2, right? Drop this plus sign down as well. And then we're going to write it so it looks all neat. I'm going to get x cubed over 3 plus 3x squared over 2 plus ln of x. And then we're going to tack our plus c at the end, just in case there was some constant in the very beginning that kind of got erased because we took a derivative, right? So that's kind of my very brief walkthrough about how to do indefinite integrals and how to think about them. So if you guys have any more questions or if you want to go over it more in depthly, come see me during my office hours. And if you guys want to practice a little bit more with your indefinite integral skills, I'll have a worksheet for you guys and you can just fill it out. It'll be pretty short, so maybe you can do it as like a warm-up to kind of test your skills and like get your brain thinking before you do like your homework or something. So that's all from me in this video. So yeah, thanks for watching. Hope you guys learned something, and if not, feel free to come see me.